As we go through life, it's often great to have pleasant surprises. But in a computer network and with systems, we don't really like surprises. We want the network to function as expected, as predicted. And using a tool like Packet Tracer can help us as we think about, okay, how is this network going to operate, or how does that protocol work, to actually verify that it does. So in this nugget, I'd like to do a couple of things, and that is to review a few of the topics that we've covered on how to do various things in Packet Tracer, and also to solve a little quarrel that a couple of coworkers in a hypothetical situation were having regarding how a protocol worked. Let me give you the details. And here's what the coworkers were having a discussion about. It wasn't really an argument, but more of a discussion. And that is that if there was two switches, switch 1 and this guy right here, switch 2, if they were connected with these crossover cables, so port 0/1 on switch 1 went to port 4 on switch 2, and on switch 1, port 2 went to port 3 respectively. When we have multiple paths in the layer 2 network, behind the scenes, there's a protocol running called STP. Now, not like the motor oil, I guess the acronym is similar, but STP is an acronym for Spanning Tree Protocol, which identifies if there's parallel paths and then blocks on one or more of those paths so we don't have a layer 2 loop in the network. We'll cover all that in the CCNA training that's coming. And one of the things about STP is that in making it work, one of these two switches is elected as the root. They call it the root bridge, but it's really a root switch that's kind of King Kong for the network and in charge. And then the other devices fall into line with that root switch. They identify the best interface to use to get to the root. And there are several tiebreakers, and one of those tiebreakers involves being the lowest. For example, the root switch is going to have the lowest bridge ID. The root ports are going to have the lowest cost to get to the root. And generally speaking, lower is better. And so at the end of the day, one of these ports in this topology is going to have to be blocking, and STP is going to do that. Now, the discussion that these two colleagues were having was which of these ports, based on which one becomes the root, which of the ports is going to go into blocking state. And that's where you and I can step in and use a tool like Packet Tracer to actually solve the question and verify that our predictions or assumptions regarding how that protocol works, that they are correct. So here's what we're going to do as part of that exercise. Number 1, we'll build the topology. And let me ask you, how long do you think it might take in Packet Tracer to build a 2-switch topology and connect them together? And you might be saying, well, Keith, that should take probably less than just a minute or so. And you'd be spot on. We've done that before in the previous videos as part of the skill. So we'll build the topology, we'll wire it up, logically wire it up in Packet Tracer, and then we'll take a look at the logical view and the physical view so we can see the gear. And then we can also, with the simulation mode, we can enable the filter to show us STP, Spanning Tree Protocol traffic that's involved. And Spanning Tree behind the scenes is using this little thing called a BPDU. That's an acronym for a Bridge Protocol Data Unit. I'm super happy about what I do, says the BPDU, because it's helping the switches identify parallel paths and block on one or more ports so we don't have a loop. So we can look at that in simulation mode, and then with our knowledge of Spanning Tree, or when you get to that part as part of your training, you can come back to this diagram and identify, okay, why did this switched environment, based on my knowledge of Spanning Tree after you've covered the topic, why are they blocking on a given port? And once again, having this tool called Packet Tracer to easily lab up and verify what those results are can help us as we confirm our understanding and knowledge of not just Spanning Tree, but most of the protocols that are covered and talked about in the CCNA program. So without further ado, let's go to Packet Tracer and build the topology, verify it, and see the results. So our first step is to build the topology. So we'll go to Network Devices down below as we've done before, select Switches from the submenu there, and let's use some switches. The 3560s I know won't require a power supply to be added manually. That'll save us a step. So we'll drag one out for switch 0, and we'll drag another switch out for the second one. And we could rename those too if we want. We'll call this switch 1 on the left, and we'll call the one on the right switch 2. Next, let's add some connectivity. Okay, how do we do that? Well, if we want to control the ports and use the exact same ports as we have in our diagram, and we'll take a peek at those real quick. So ports 1 and 2 and 4 and 3. So 1 goes to 4 and 2 goes to 3. So if we want to use those, we don't want to use the automatic connector tool. We want to go ahead and manually select crossover cables for those connections. So back in Packet Tracer, let me zoom in a little bit here. I'm going to zoom in so we can see this a little bit better and scroll over a little bit. Fantastic. So down here, we'll click on the little lightning bolt for connections, and then over to the right, if we hover over these icons, they show us exactly which cables they are, And this little dotted line one here is the copper crossover cable. So we'll click on that and go from switch 1 from its port 0/1. So I selected that from a menu, and going to switch 2 to its port 4. So I'll select that as well. And based on my preferences in Packet Tracer, I have it showing us the labels. And so they're going through Spanning Tree right now, just to make sure there's not a layer 2 loop. They'll become green here in just a moment. Next, let's put in the second connection. So we'll go back to our connections tool. We'll click on the crossover cable, and on switch 1, we'll click it. We'll select port 2, and then we'll click on switch 2, and we'll go ahead and click on port number 3 based on our plan. So there is our 2 connections between these 2 switches, and Spanning Tree is working on right now identifying the root switch, the root bridge, and then all the other pieces that are going to allow the connectivity and not have a loop. So we'll give that just a moment to complete. And while that's completing, let's take a look at our next step. So our next step, we built the topology. Now let's take a look at the physical and logical views while it's converging with Spanning Tree. Now, my question for you is, do you recall how to go ahead and look at the physical rack? It was a 2-step process. One, we're going to click on physical up here in the upper left. And then after we click on physical, we're going to go ahead to the compass, the navigation panel, and then go down to rack off that list, and then click on jump to, and boom, there's the rack. And there's our 2 switches. So we have switch 1 and switch 2, and it also includes the little LEDs. So we can see that right above here, right above port number 1 on switch 1, it's amber, and that's indicating that that is blocking from a Spanning Tree perspective, and all the other ports are forwarding. And if we go back to the logical view, that also reinforces that same detail. So as we make our way through this checklist, we built the topology, check. We viewed the physical and logical views, check. Now next, let's go ahead into simulation mode and look at the STP protocol. So back here in Packet Tracer, we'll go ahead and click on the simulation option here on the bottom right. We'll click on the show all/none until we're looking at nothing, meaning that we have no visible events. And then we're just going to add in just Spanning Tree. So we'll click on Edit Filters, and it's not here on the IPv4 tab. It's not going to be on the IPv6 tab. And we'll take a look at the miscellaneous tab, and there it is. There's STP. I was looking for BPDU because behind the scenes, that's what Spanning Tree Protocol is using. So we'll click on the checkbox next to STP, and then go ahead and close that, verify that's here in our list, and then we'll go ahead and play it. So I'm going to click on the play button, so it'll just go ahead and happen. There's also speed control right here. So if you want to see it faster or slower, you can go ahead and use the speed control right here. So these are Spanning Tree Protocol. If we click on one of them, this is BPDUs as part of Spanning Tree, and that's what Spanning Tree is using. So let me go ahead and stop this simulation. I'm going to click on Show All/None, and then go back to Real Time. And one of the things about Spanning Tree is that lower, it's like golf. You know, golf, a lower score is better. In Spanning Tree Protocol, lower is better. The lower the bridge ID, the more likelihood of becoming the root switch, or the root bridge. The lower your cost to get to the root, the more chances of that port being favored to be the root port. And if there's a tie in the middle, the lowest port is better than a higher port. And so if we take a look at this, so based on this output, this implies that switch 2 is the root of this Spanning Tree topology, and it also implies that switch 1 is forwarding here on FA 0/2, but it is blocking from a Spanning Tree perspective on FA 0/1. Yet FA 0/1 is a lower port. So I'm going to save that mystery until you had an opportunity to go through our Spanning Tree Protocol training here at CVT Nuggets, which once you do that, you'll understand the details of how that plays in and why that's the case. And the benefit here is that it's wonderful that we can use a tool like Packet Tracer to build the topology, verify the topology, and then take a look at the network traffic to help us discover and also reinforce concepts about the protocols that we're using, including IP, IPv4, IPv6, Spanning Tree, and the list goes on. And one last thing while we're here is that if we wanted to confirm that switch 2 really is the root, we can simply click on it right here, go to the CLI, which we're at, press enter, and from here we can use the command show Spanning Tree. And sure enough, right there, this bridge is the root, it's the king. So let's take a quick look at our checklist here. We built the topology, we viewed the physical and logical views, we looked in simulation mode at the traffic regarding Spanning Tree, including the BPDU information, and each of those elements, using simulation mode, looking at the physical view, being able to build topologies, are abilities and capabilities that we now have as a result of going through these videos together. So I want to thank you for joining me in this journey through the world of Packet Tracer. And I can hardly wait to join you with the other training we have regarding Cisco right here at CBT Nuggets. And I've got a challenge for you that I think you're up to, and that is this. I would like you to take the idea or the concept of every time you see something that's being taught on Cisco devices, switches, routers, etc., I'd like you to have the idea, you know what, I'm going to reinforce that by practicing. And whether that's some physical gear that you have, or whether it's Packet Tracer, or maybe you're using Viral or some other tool or system, the key is get that hands-on experience, because the more times you practice it, the more muscle memory and the more habit that will be. And those skills in Cisco and Cisco systems are very, very valuable to you and to your employer. And that's why I'd encourage you to start building them now and practice everything that you see. So I'll see you in some future videos. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.